Okay, I'm back recording for part 3 of the video. I apologize that it stopped the first 2 times. However, this is part 3, and in part 3, we're going to finish out question number 2 and question number 3. I will go back to reading question number 2. What is the product, which we know is multiply, of the slope of g of x and the slope of h of x? So now that I have identified the key parts of the problem, I'm going to go now back up to my functions, f of x, g of x, and h of x. I see here that it wants me to look at g of x and h of x. So the slope of g of x. Now, I have to realize that this is a graph. So it would be a little bit different finding the slope versus a table and an equation. So for the graph, I know that the slope is rise over run, and I have to identify 2 points here. I have -2, 0, and 0, 2. Or I can easily do rise over run. 1, 2, 3, 4. So I rose 4, and I ran 1, 2, 3, 4. So the slope of g of x is 4 over 4, or in other words, 1. And so now I'm going to look at the equation to find the slope of h of x. So here I am again. And as we saw in the last problem, b was the y-intercept, so that only leaves us with m to be the slope, and in this case, m is 3. So the slope of h of x is 3. Now, go back to the problem to figure out what does it want me to do with the 3 and the 1. And right here it says, what is the product of the slope? So I have g of x times h of x. So g of x is 1 times h of x, which is 3, and that'll give me 3. So the product of both of these slopes is 3. Now I'm going to move the camera up just a little bit more so we can see problem number 3. Excuse me while I lift this up. Okay, so question number 3 says, what is the y-intercept of h of x subtracted from the y-intercept of g of x? Okay, as we did in problems number 1 and 2, I'm going to go and highlight that vocabulary. So I see here that I have the y-intercept of h of x. I know I'm going to have to do something with that, so I'm going to underline y-intercept, not to confuse it with the slope. Subtract it from. And as we all know by now, subtracted from is a very fancy way of saying minus or difference, as we saw in problem number 1. And last but not least, we have the y-intercept of g of x. Again, I see y-intercept, so I'm going to draw a little squiggly line to let me know I'm going to compare. So the y-intercept of h of x, which we found back in problem number 1, is -5. So I'm going to go and put my -5. If you forgot how to find it, easily look at y equals mx plus b. B is your y-intercept, and that's your -5. And the y-intercept of g of x. So g of x, we have not quite looked at that y-intercept. So here again, g of x is this line, and I know y-intercept is wherever this line crosses the y-axis. And we said that point was 0, 2, and I want the y-intercept, so that would be 2 because that would be the y value. So then I'm going to put g of x, and I'm going to put it 2. That's a positive 2. Now, I need to figure out what I want to do with the -5 and the 2. It says in the problem, subtract it from. So if I were to write this normally, how I see it, I see h of x minus g of x. However, subtract it from is a very fancy way of saying less than. So, and you know, when we see less than, we have to flip it. We have to rearrange the order. So actually what we really want is g of x minus h of x. We want to take away from the value of g of x. And I will slide this up a little bit more so it's easily read. Okay, so again, just to repeat that, because this is very important, subtracted from, even though it means minus, it does the same thing as less than. It tells you that you need to flip the order that you originally wrote it in. So instead of saying h of x minus g of x, which we have here, it's really g of x minus h of x. And the value of g of x is 2 minus negative 5. And we all know two negatives give you a positive. So here we really have 2 plus 5, which is 7. So h of x subtracted from g of x, those intercepts, the difference is 7. Okay, thank you so much. Hope you enjoyed the video today. Sorry it was in 3 parts.